Okay, so with these problems, we want to write each of them in roster form, and that's not necessarily always the case, it's just the instructions here. Now, roster form is when we list numbers out one after the other with brackets to surround the numbers. So if I wanted to list all the counting or natural numbers n, usually written with a double stroke there, I would just write that n is equal to 1, 2, 3, and so forth. This is just telling me that the natural numbers can be thought of as starting at 1 and then including 2, 3, and every whole number after that, right? The dot 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 implies that this pattern keeps going. So we have this set interval notation that we're trying to rewrite in roster form. And at first this certainly seems intimidating, all these symbols, but if we break it into pieces and think about what each thing means, we can quickly rewrite these in roster form. So for the first problem, the first thing they tell us is that x is an element of the natural numbers right here. Now this e symbol, sometimes written a little bit differently than this, but it means that x, or in other words, every number you're given, is a part of, right, an element of, or part of the natural numbers. So if that was only the only part of this question, we could just write what we just wrote here in roster form, right? These are the natural numbers. They're just saying that in a different way. However, we have this other symbol right here and these other brackets to think about as well. Now, before I usually think about the middle symbol, which happens to mean intersection, or in other words, what do these numbers over here, the natural numbers, have in common or share with these numbers over here, before I even do that, I really try to evaluate the second piece of the puzzle. If you think about this interval right here, it's saying that x is greater than or equal to 0, so it could be anything greater than or equal to 0, and anything less than or equal to 3. So in other words, it's between 0 and 3. Now that can be an infinite set of numbers, right? We can have fractions and decimals in there. However, this is definitely a finite set because we only have, right, natural numbers. We're told over here that x is the element of natural numbers. So they're asking us what numbers are natural numbers and between 0 and 3, and that's it. So what does that mean? Well, we can pick the numbers 1 and 2 and 3, and that's it, we're done. Now I don't pick 0 here, even though x could be greater than or equal to 0. X is the natural numbers, and those do not usually include 0. However, of course, it could be less than or equal to 3. So that's it. This long expression here, with all these symbols, is really just representing the numbers 1, 2, and 3. Now, you might think that it's a little ridiculous to write all this for numbers 1, 2, and 3, and it might be. However, this language here, these symbols, allow us to be really precise and describe very complicated sets other than just 1, 2, and 3. So it's just introducing the connection between the language. So here in the second part, we have a different setup, but the idea is the same. We want to analyze both pieces here that are caught in between the brackets, and then we're taking the intersection of them. So what do they both have in common? The first brackets we can read as take any number x. You have a line or a colon there that means such that. So we have any number such that when you take that number x, right, and divide it by 4, what happens? We'll take any number, divide it by 4, and it should be an element of the integers. So right from the start, that tells me that, oh, I could divide x by 4, and the result has to be in the integers. So for example, 0 over 4, what's that? Well, that's 0, and that is an integer, right? Z is the symbol for integers, and you might remember what that set is in roster form. That's just 0, 1, -1, 2, and -2, right, and so on. In other words, integers are positive and negative whole numbers. So this certainly qualifies. So just to get a sense of what values of x we can choose, x works. However, does 1 work? Well, 1 does not work, because if we take 1 and divide it by 4, what happens? Well, that's equal to 0.25, or a fourth, and that is not an element of the integers, right? You write the e and then cross it out. So 1 wouldn't work, and would 2 work? Again, 2 wouldn't work for the same reason. You would get, right, another decimal. 3 wouldn't work, but 4 would. right? 4 over 4 is 1, and 1 is an element of the integers. So if we look at this so far, 0 works and 4 works. And if you think about what's happening, when you divide something by 4 and the result's still an integer, that means the values you can use are 0 and then multiples of 4, right? Multiples, so positive and negative multiples of 4. So for example, we could use 4, we can use 8, right? If we use 8 over 4, that gives us what? Well, 8 divided by 4 is 2. And 2 is okay, it's an element of the integers. 16 would work. 16 divided by 4 is 4, and that's also an integer. Of course, we also could use negative, so I could use negative 4, negative 8, and so forth. For example, negative 4 over 4 is negative 1, and that is an integer. So far, if we were just analyzing these numbers right here, we would be done, right? We would basically say 0 and any positive or negative multiple of 4. But before we even think about that, look at the intersection, right? We're saying, what does that have in common with the second group right here? And this is just saying that x is something greater than or equal to 3, but less than or equal to 6. So on face value there, if we write that in roster form, we can get 3, right, any decimal, and so forth, all the way up to 4, all the way up to 5, and all the way up to 6, and all the infinite numbers in between. So you notice, I think, that what they have in common is one thing, one element and one item only. That's the number 4. Right? Both groups share 4, and that's their intersection. So here, the only thing they have in common is 4, so that would be your answer. Now the last problem here, we have a similar setup where, as before. However, notice that the brackets start here and end there. So all the information is set between the brackets. And this piece right here tells us the interval. In other words, what is the range of x? What is the lowest value, negative 3, and the highest value, positive 3? And then the next part defines the numbers in between, right? You know the endpoints, but what's happening in between? So here, if we set this up, we think that x is something between, well, we can read it x such that, right? The colon means such that, right? X is greater than or equal to negative 3, but less than or equal to 3. So it's between those two, and it's an element of the integers. So in roster form, if we think about our options here, we start at negative 3, again, because x could be greater than or equal to negative 3. Our next number is negative 2. We can't use any fractions because we have only integers. And then negative 1 and so forth, all the way up to 3. And that's it. So again, when you evaluate these things, don't be overwhelmed by the symbols, and don't feel like you're doing something wrong if it takes a very long time to read this stuff. Sometimes it takes a long time to get a hang of these symbols. If you remember when you first learned to read, you're going through a similar experience here, but now you're dealing also with numerical values. So it's a big challenge, but an exciting one. All right, thanks.